we're going to go over some Nernst equation problems. You're either watching these to review what we did in class, or maybe we didn't get them covered in class, or you were absent from class. So we'll start with number 77A and B on page 742. So 77A asks, well, it says an electrochemical cell consists of a standard hydrogen electrode and a copper metal electrode. What is the potential of the cell at 25 degrees Celsius if the copper electrode placed in a solution in which copper ions have a concentration of 2.5 times 10 to the negative fourth molar? So in this case, we are not at standard conditions because we have a concentration that is not 1 molar for our copper solution. So let's do part A first. And so we have, we're going to write our half reactions, and then our cell potential for hydrogen, which the hydrogen electrode is at a standard condition, it's 0 volts. And then for the copper, and these are from your standard reduction potential table. And so our balanced equation, you can see we have 2 electrons on both sides, so those will cancel. And so the Nernst equation, the cell potential not at standard conditions equals the standard cell potential minus 0.0591 divided by N, which is the number of moles of electrons, the log of Q, which is products divided by reactants. It does not include pure solids or liquids. So concentration of the hydrogen ions squared, because there's a coefficient of 2. Concentration of the copper, there's only 1. And then the pressure of the hydrogen gas. So I'm going to plug in my values. We calculated the cell potential at 0.34 volts. There are 2 moles of electrons. I have those circled up in our half reactions. The concentration of the hydrogen ions was the standard 1 molar. The concentration of the copper cations was given to us as 2.5 times 10 to the negative fourth molar. And our hydrogen is at a standard pressure of 1 atmosphere. When you solve this, the cell potential is 0.23 volts. So let's look at 77B. So for B, the copper electrode, so we still have our hydrogen and copper cells. The copper electrode is placed in a solution of unknown copper ion concentration. We have the measured potential, and that should say here 0.195 volts. Little typo there. We want to find the copper cation concentration. So in B, we're going to be using the same half reactions, total reactions, we know our cell potential is 0.34. We don't have to do that work again. So for the equation, E of the cell equals standard cell potential minus 0.0591 divided by n, the log of Q, which is products divided by reactants. So this was measured. This was calculated in A. This is what we're trying to find. So I'm going to plug in my numbers here. It was measured at 0.195 volts. We have 0.34 volts minus 0.0591 divided by 2 moles of electrons times the log of the concentration of hydrogen ions divided by the concentration of copper cations, which is what we're trying to find, times the pressure of the hydrogen gas. So I'm going to walk you through how to do this calculation. As far as work, I would expect to see the equation. You wouldn't have to write like where I put arrows to give you those notes, but you would write the equation you used, you would plug in your numbers, and then you can use your calculator to give me the answer. But I'm going to walk through the work. We would first subtract both sides by 0.34. So then we got to keep track of sig figs, but still carry additional sig figs. So I would be looking at, since I'm subtracting places behind the decimal point, and so I would need 2 places behind the decimal point. This would equal and then we would have the log, and I'm just going to put in an X for the copper cations. So then I'm going to divide by 2 over here, still knowing I need 2 sig figs there. And I have 3. And then I'm going to divide both sides by the 0.0295, the negative 0.02955. That cancels, and I'm at 4.906. 93794. I should still have 2 sig figs at this point, equals log of 1 over x. And so when I'm going to take, next I'm going to take the inverse of the log. When I do that, it's an exponential. And so it would be 10 to the 4.906 93794 would equal 1 over x. When I find that, it is 80,711. I'm still keeping track. 0.96859 equals 1 over x. Still need 2 sig figs. So then I'm going to solve for x. And so 1 divided by 80,000 is going to equal x. We know that x equals our concentration of copper cations. And so with 2 sig figs, I would get 1.2 times 10 to the negative 5th molar. Again, you wouldn't have to show me all of that work. What I would expect to see is this equation, your numbers plugged in, and then your answer. If you have questions on this problem, I will be having office hours later this week to go over any questions with the Nernst equation. And there will be another video with the other problem we were supposed to get to in class.